So in part C, now we're going to twirl it in a vertical circle. Now in a vertical circle, at some point, where it's going to be most likely to break, where is the string most likely going to break if you twirl something in a vertical circle? At the bottom. Because at the bottom, the weight's working against you, so the tension even has to be greater because the weight's not helping at all. So in part C, we're going to have a vertical circle. So I'm going to take this and make it into, now look at the difference between the two pictures. In part A and B, we're making the circle look like that. So that's how we represent horizontal circles. This is how we represent vertical circles. That way I know you're drawing a vertical circle. So since we're looking at the braking strength, the maximum velocity, then I'm going to put on this picture, I'm going to put the weight, well, I'm going to have the tension in that direction and the weight in the opposite direction. So there's my picture. There's the tension, and there's the weight. I don't have to worry about normal force or anything in this one, but that's it. So my descriptive equation, if I sum up my centripetal forces, I've got T towards the center of the circle and weight away from the center of the circle, so I'm going to get T minus W equals, again, we're solving for a velocity, so it equals mv squared over r. So at this point, I know the mass, so I can replace this with mg. I know the mass, I know the r, and I know the t. So it's just algebraically rearrange that equation to solve for v. So to do that, I'm going to multiply everything by r, so I'll have an RT, and I'm going to write this as RMG. And then I'm going to divide by m and take the square root. So again, in one step, what I would get is that v, I don't like to spend a lot of time on the algebra. If you need to take more steps, that's fine. But again, I'm trying to teach the physics, and if I'm spending all this time doing the algebra, then that's supposed to be a prerequisite. So multiplying everything by r, so I'm going to have RT minus r, and like I said, I'm replacing w with mg. So it's going to be RMG. So that will get rid of this, because this has now been brought over. And now I'm going to divide by m and take the square root. So this is going to be divided by m, and then the square root, and plugging in those numbers, and that's going to give you the v. So we're going to get v equals the square root of RT minus RMG all over m. And we put in the numbers. The R, I forget what was the R. The R was 2.5 meters. So that's going to go there. And that's going to go there. The T was 500. The M was at 1.6. 1.6 kilograms. So that goes there and there. And the G is 9.8 meters per second squared. And again, that will give you the answer in meters per second. And if you solve that, I think that came out to be 27.5. So all the numbers were sort of close, but this was the one that was most likely, out of the three choices, that's the one that the string would break first. If you just slowly increase the speed, that's going to break first. So anything above 27.5, it's going to snap. Any questions? All right, so that was